We're on. We're live. I figured out full screen mode again. Ta-da! Isn't that nice? So we're going to do partial fraction decomposition and a wee bit of trig. If you happen to know where some trig identities are, it'd be awesome. Yes, I will give you trig identities. I just don't want to give you too much. That would be no good. But we'll get there in a minute. This is the decomposition stuff, and if you can remember, we are going to factor the denominator of this thing into something kind of nice. In this case, it's going to be linear factors. So if you are not thinking factoring at the moment, let's get it back in the brain. So here's factors of negative 11 and 2. And the goal is pair it up so I get 1 in the middle, if at all possible. And I think, does this one factor? Or am I?
Yeah, he's quadratic formula.
That sounds awful.
It is awful.
And what do you get? Did you do it by any chance? Didn't work out. Did anyone do it by
The
chance?
bottom's 3, that's why.
Which one?
It's not 11, it's 3.
Negative x minus 3.
Oh, hallelujah. That's way better than what I had here. Does that sound better?
Yeah. It's a factor, not negative 1.
Does that look like the right numbers now?
Yeah.
Cool. So we need that factor. So how might that, we're making like maybe 2 minus 3. So if I pair the 2 and the 1, when I do this, the factors down below, this is how I look at it anyway. That means in my factors here, I know for sure it's a 2x and it's going to be a 1x. My 2 got paired with 1, so I put them on opposite ends, whatever I pair my 2 with. And then the other 2 go inside. Now the 1x is right here. That's already part of it, so it's already got a place. So the minus 3 is the only thing left to put into factored form. Okay, so it factors nicely. And then up top it's 4x minus 11 still. That's step number 1, is you got to factor the denominator. And then decomposition is rewriting this as some kind of something over 2 minus x minus 3 plus blank over x plus 1. We're rewriting it into the sum of 2 fractions because mathematically there's advantages to such a decomposition, to break it up. Okay. So how do we get a and b is the big key. And in this situation, this is the relatively nice version. We just need to add those 2 fractions that we see on the right-hand side. So I'm going to use the trick, and you tell me if that throws you off. I'm going to do a times x plus 1 plus b times 2x minus 3 over the product of these 2. And I'm not going to put them together yet. Now, what I've done is that now I have these guys equal to each other. And I think it's really important to keep rewriting this, because if I see errors, it's usually because somebody starts to take shortcuts. Being all smart and all can have its disadvantages. So there you go. Those are definitely equal. And since I know the numerators are already equal, what I'm going to do is just set these, since the denominators are already equal, I'm just setting numerators equal at this point. So I'm trying to figure out, all right, 4x minus 11 is equal to this dude over here. Okay, and then the next piece is I'm going to rearrange the right-hand side so that I can line it up and make it look like the left-hand side and compare the values in here. So that's the end goal is, so you want to simplify the right-hand side, like distribute the A, distribute the B, combine like terms. And this is b 2x, 2bx, minus 3b. So that's nice. And in the end, if I'm going to find out what a and b are, the trick we use is I'm going to line up, I'm going to combine like terms so I can see something's going to be equal to 4. I used the wrong color. So some combination of a plus b or some other values is going to make 4, and then whatever numbers are left on the end have to add up to negative 11. So I'm rewriting the right hand side so that I can compare it to 4 and negative 11. That means combining like terms, like things that have an x with it, add them up. A plus 2b, x. And then the other two numbers don't have x's with them, so those are considered like terms. They're just numbers. A minus 3b. So combining like terms, you have to think of a and b as being numbers, as if they were values you knew. So now, what I'm seeing is, now that they're all lined up and kind of match, I can see, okay, I want the 4 and these numbers to match, and I want the 11, negative 11, and these numbers to be the same. That's A and B have to be picked so that that is a true statement. That means, and this is also a key step that gets missed a lot, the A plus 2B part is going to have to be 4 if this is going to work. The A minus 3B part, the pink part, has to be negative 11. This is a system of equations. 2 variables, 2 equations. It can be solved because the variables match the number of equations. You can choose your favorite method: substitution, elimination, make a matrix. You go to town and solve it any way you want, but I just want to know the value of A and B. I don't know, you can choose. I've never tried elimination. I haven't done that with you guys for this one. I could. Would that be cool? If I went through and multiplied the bottom row by negative and did elimination and added down, wouldn't that be cool? Then I'd get 0A, and then this would be 5B. And that'd be 15. I'd say, oh man, B is just 3. Cool. Now I need to find A. So you take your 3 and put it back in anywhere you like. One of those equations, I'll put it up here. Okay, that'd be 6. Subtract 6, so that'd be negative 2. A is negative 2. So therefore, if B is 3, then A be negative 2. I put them back, and I write my equation. So I'm going to zoom out so you can see the whole original. But A and B go back into the original equation. So A is negative 2, B is 3. So here it goes. Negative 2. And B is 3. Ta-da! Decomposed with non-repeating linear factors. It's the kind of decomposition I want you to know about. Okay. Don't mind me, I'm just making it smaller.